Today I want to show you how pretty much every automatic transmission that has planetary gear sets works. And it's actually pretty simple. And I think once you see this demonstration, all the parts that you've taken out of these transmissions that we've disassembled, these Allisons, and any other automatic transmission that you disassemble will suddenly make sense as to why they're there and what they do. But this is something that, as a young technician, I couldn't grasp at first, but finally figured it out. So we've got, in a planetary gear set style transmission, we have a planetary gear set. And a planetary gear set consists of, anybody know what this part's called? A sun gear that's in the middle. So think of our solar system. We have planet gears that, of course, orbit around the sun gear, or the sun gear rotates inside of them. Those planet gears, these are the planet gears, are held in place by this part here called a carrier. So this is the planet carrier. It carries the planets. And that orbits around inside of, anybody know what that's called? Sometimes it's called an internal gear, sometimes it's called an annulus gear. Most of the time that I've seen, it's called a ring gear. So think of like a ring on your finger, ring gear. So we've got a ring gear, a planet carrier, and a sun gear. Now mathematically, if you change the size of the sun gear versus the planet gears and leave the ring gear size alone, you can change the gear ratios that this planetary gear set can create. And all planetary gear sets can create some useful gear ratios and some absolutely crazy gear ratios that are not useful. They can all create two underdrive gear ratios. And what does underdrive mean?
Like it's less than direct drive.
Okay, so yeah, like low gear in your transmission, first, second, third, whatever it may be. The output shaft of the transmission is going to be turning slower than the input shaft of the transmission. So that's underdrive. So there's two underdrive gear ratios. One is a usable one is unusable. It's a gear ratio that wouldn't work, although it is underdrive. There's also two overdrive gear ratios. So overdrive means output shaft turns faster than the input shaft. So one of those is usable and the other one is insanely unusable. So on most overdrive transmissions today, the final overdrive gear ratio is around 0.7 turns of the crankshaft to 1 turn of the output shaft. I've seen as low as 0.5 turns. Half a turn of the engine crankshaft gives you 1 turn of the output shaft, but not very often. Well, one of the unusable gear ratios in overdrive on most planetary gear sets is like 0.2. So it just, it's mega overdrive. It's not going to work. There's also two reverse gear ratios. So one of them is usable, one of them is not. And then there is what's called direct drive. And direct drive means what? A one-to-one input. The what? 1 turn in equals 1 turn out. So that's direct drive. So these gears right here can make up a single planetary gear set, and typically in anybody's automatic transmission, you can get 2 forward gears out of this, one of the underdrive gear ratios and a direct drive. You can also get a reverse gear ratio out of this, and possibly an overdrive depending on what the gear ratio is. But typically, for each 2 gears in a transmission, you need 1 set of planetary gears. So the old Power Glide transmission had one planetary gear set in it. It was a 2-speed. But when we have a 4-speed transmission, it has 2 planetary gear sets in it, and 5, 6, and so on. This Allison transmission that we're working on in class is a 5 or a 6-speed, and it has 3 planetary gear sets in it. So pretty much 2 gears per planetary gear set. Now there are exceptions. There are some sneaky configurations where they can hook multiple pieces or multiple gear sets together with a common sun gear or a common carrier. And we'll talk about some of those later, but let's stick with the basic ones first. Just a sun gear, a planet gear, or planet carrier with planet gears, and a ring gear. Now, these gears happen to be out of a General Motors 4L60E transmission. So that Chevrolet Tahoe we had in here, the 2007 Tahoe with 4-speed that we had for the manual drivetrain class, that had these were called the input planetary gear set, and it had an output planetary gear set also, but 2 planetary gear sets. So let's do a comparison with the Allison. So here's 4L60E sun gear. Here's Allison sun gear. A slight change in size, but it's all relative. Here is the 4L60E carrier, but I can't even lift it. That's the carrier from the Allison, and it has 3 of them that are very similar sized. And then of course, here's a ring gear also. So obviously a much bigger, more heavy duty transmission. Yes?
Is the ring gear like a ring gear and a differential?
No.
Or is it a different concept?
Different concept. It's called a ring gear. Well, you can still get it's similar in some ways because you can have a similar gear reduction or overdrive, but planetary gear sets are compact. And one of the neat things about planetary gear sets that allows them to be used in automatic transmissions is how you transfer power through a planetary gear set. So unlike a manual transmission where we had synchronizers and actually had to move shift sleeves and everything in and out to shift different gears, a planetary gear set right now, this one on the 4L60E, if this sun gear was hooked to the input shaft and this was hooked to the output shaft or drive shaft, and this is hooked to the ring gear, by the way. Notice right now, if I turn the sun gear, there's no power flowing through. The output shaft does not turn. So instead, we have to come in and we have to hold one of these 3 pieces from rotating and rotate one of the others. So on a planetary gear set, to get reverse, to get forward, to get any of those usable or unusable gear ratios, out of all of 3 pieces, you always have to hold one and drive the other one, or drive, there's 3 pieces, so you're going to hook power to one, you're going to stop one from rotating, and then the one that's left over will be your output to your wheels. And so in this case, if I held the carrier from rotating and turned the sun gear, looks like I've got reverse right there. So there's one reverse gear ratio. But if I hold the sun gear from rotating, and let's say we hook to the carrier to the output shaft rather than the ring gear, so I'm holding the ring gear, I'm going to turn the sun gear. If we could connect the planet carrier to the wheels, notice as I turn the sun gear, the planet carrier turns with the sun gear in the same direction, but it's actually turning a little bit slower. So this is an underdrive gear ratio. So what I'm trying to show you, and it's much easier to show it on the Allison just because of how it's designed, is that once again, to get power through any planetary gear set, you have to stop one of the three pieces. We could stop the, well, watch this, we'll go into overdrive. I'll hold the sun gear from rotating, and then I'll turn the planet carrier, and now the ring gear turns faster than the planet carrier that I'm rotating, so there's an overdrive. But we have to hold one of the three pieces, turn one of the other three to get underdrive, overdrive, or reverse. Now the direct drive is unique because in direct drive, it's the only one where you do not hold anything and prevent it from rotating. Instead, you connect power to any two of the three pieces at the same time. So if I connect power to the sun gear and the planet carrier and rotate them together, it forces the ring gear to turn with it. If I hook power to the sun and the ring, it forces the carrier to turn with it. If I hook power to the carrier and the ring, it forces the sun to turn with it. So there's three different ways to get direct drive, yeah.
When you say connect power to it, are you meaning, is this how we're using the hydraulic solenoids to control the pressure, to push the pressure?
We're coming to that, but just when I say connect power, I mean somehow we're hooking the engine to one of these three pieces. So engine power coming in, the output is going to move the vehicle through transaxle or rear axle, whatever it may be. So what I want to show you now that we've seen basic pieces of a planetary gear set is how the Allison transmission with its three planetary gear sets can give us 5 or 6 speeds plus reverse. So let me get these two pieces. Actually, let me pass these around. You can take a look at them. All right, so let's start. Let me back up over here. On the bench, and this is what I want you guys to do with your Allisons today. We've got this red holding fixture that sticks out, and when you got your transmission disassembled, you're going to have, what do you think the name of this part is with these little gears on it? Planet carrier. So there are 3 planetary gear sets in the Allison transmission. This planet carrier is actually connected to the output shaft. So this flange right here, notice, turns with the output shaft and the planet carrier. This piece right here with all these notches in it is the parking gear. And I just wanted to show you that Allison has a massive parking gear. I don't know how wide that is, an inch and a quarter or so. But this is what's called the parking pawl. And notice it's got this little hook on it. And have you ever accidentally on the hoist had the vehicle in gear, tires rotating, and then you accidentally forgot to step on the brake and you put it in park and you hear this grinding noise? That grinding noise is this park pawl trying to grab until it finally does. Now, of course, it was never meant to do that, and eventually it would cause damage to the parking pawl or the parking gear, both of which are replaceable, but very expensive, of course. But on the Allison, this is a gigantic, this is easily 2 or 3 times the size of a regular parking pawl, say in that 4L60E that we had. It's a monster. It's made to hold a lot of weight. But
when I mentioned that the last cross-country race, like when I missed class that day, we had one of the Weaver buses, and that was engaged, so the whole bus like kept on rolling and went straight into a car.
yeah, it's not meant to stop the vehicle. It's meant to prevent it from rolling once you are stopped. Okay, so this is one of 3 planet carriers. Here's the other 2 right here. So we've got the P2 gear set, the P3 gear set, and the P1 gear set. I don't have it labeled over here, but for Allison, as far as Allison's terms, P1 just means planetary gear set number 1, P2's gear set 2, P3's gear set 3. And they're in that order from front to rear of the transmission. So the P1 obviously is closer to the front of the transmission, and then P2, and then P3. So those are the three planetary gear sets. So now I want to start assembling these pieces, or assembling the planetary gear sets so you can see how this thing works. So every planet carrier has to have a sun gear to go with it. So here's a monstrous beefy sun gear. By the way, in between every one of these rotating pieces is a bearing. And those bearings, there's a bearing down in here that sits in this groove. When you get these gears lined up, which sometimes can be a little bit of a challenge, they're finally lined up, do not do this. You might as well take a hammer and smack the bearing with it, because that thing probably weighs a pound, that sun gear all by itself. So you can damage the bearing itself. So there's a sun gear that went inside the planet carrier, and over here the ring gear for that gear set also happens to be connected to the planet carrier for the P2 gear set. So they connected a ring gear and a planet carrier together. This is called a compound gear set. So a simple gear set is just that 4L60E one I showed you, just with the three individual pieces. But a compound planetary gear set is one where they start hooking them together. Yes. So before I can put that ring gear on, then there's another sun gear that needs to sit on top of this. And guys, when you put this Allison together, there's a spacer that goes in between these two sun gears, like that. There's a bearing, of course, that sits on top. Notice this bearing has been destroyed. It's broken. You see the bearing? That's because when whoever lined this up, before we dyno tested it, did not get it centered in the sun gear. They had it off to the side. It was the previous troublesome student. And when they put it together, it just kind of squished everything and broke it. So anyway, there's two sun gears, and then in this case there's what's called our intermediate shaft. So on this transmission, we've got the input shaft from the torque converter and the engine. We've got the output shaft that goes to our drive line or transfer case. Just set them on the table there. And then there's a shaft in the middle of these that is going to connect. Oh, got that upside down. Is going to connect those together. It's kind of a trick. Yes.
The parking gear is on the last gear set.
No, I had it right the first time. Parking gear what?
The parking gear is on the last gear set on the back of the transmission. Right? Did they have put it anywhere on the transmission, or does it have to be on the back, on the output shaft?
Notice it's on the output shaft because the parking gear physically stops the drive shaft from rotating, which stops the ring and pinion from rotating, which stops the differential case,
So it's literally
pinion
just
pin,
holding the
axle shaft. That's the only thing holding you from rotating, from rolling. Which, if you think about it, if you're parking on a pretty steep hill and all you do is throw it in park,
It could let go.
it can let go
And
and
that's what
did
causes
let
that
go.
big clunk
Yeah.
because it's flipping off.
Exactly. Okay, so I've got an intermediate shaft finally installed the right orientation. Our two sun gears, we've got one planet carrier. So now we've got the second planet carrier with the ring gear. It's going to go with it. Once again, this is a heavy part. We've got bearings in between. So we're going to have to line this up and carefully set it down. So now inside here, I've got a sun gear, a planet carrier, and a ring gear for the P3 gear set. But I've also got a sun gear and a planet carrier and planet gears for the P2 gear set that's next. So notice the P2 gear set ring gear is also connected to the P1 gear set planet carrier. And there's a bearing right here that needs to be centered. So we're going to set that in place and set it down.
So the gears that drive the vehicle are the outside of the ring gears?
We're coming to that. Hang on to that question. All right, so now we need another sun gear, which is right here, and another ring gear right here. So let's put the ring gear on first. You guys are going to have to assemble your transmissions this same way. And then the sun gear is actually part of that big rotating clutch housing. Yes?
You said the relationship of changing the gear ratio is changing the size of the sun gear to the
planet
to
gears.
the planet gears, right?
Yes.
So the ring gear size isn't changing on any of those.
That's right. It's the same.
So is it like a diff where you take the size of the sun gear and you divide it by how many teeth are on the planet gear to get the ratio?
The math is right there if you want it.
Never mind. Okay, so why, we just asked, like, how come you said the 4L60E isn't compounded? How come it's not?
No, I said that one gear set
Oh, that
was
one
a simple gear set.
Oh, okay.
But in reality, it does connect to the output gear set and becomes a compound gear
Okay.
set. But a simple gear set is just like the Power Glide had. It's just a single planetary gear set. The sun gear for the P1 gear set is connected to the rotating clutch module. And can I get you to just grab that whole that big housing with the input shaft right there? Yeah, set that right over here. Just right there. All right, this is the rotating clutch module, and this is just the bottom of it. So all of you are taking this out. You either have it out or will take it out. Today we'll take that apart even further because inside of that are a couple of clutch packs that we need to talk about. But what I wanted to show you on this sun gear is that it is splined directly to this piece of metal that is splined on these notches directly to this housing that is splined directly to our input shaft, which means if our input shaft turns at all, and of course I can't get this to line up, there we go. If the input shaft turns at all, so does this sun gear. It requires no computer, it requires no clutches, it's just a direct connection to the engine once the torque converter transfers its power. We're going to talk about how torque converters work Friday morning. I've got a demonstration on that to show you, but anyway, planetary or sun gear is our third sun gear. So now I'm going to set that right in here just like that. So now we've got 3 complete planetary gear sets here. We've got the P1 gear set, I just put the sun gear in. We've got the ring gear I just put on, and then the planet carrier. Its planet carrier is connected to the sun gear, the ring gear of the next planet gear set, and so on. But we've got 3 complete gear sets. They're all connected to each other. And so now we're ready to add a few additional parts. This shaft, the intermediate shaft that I showed you earlier, has some splines right here. Well, this shaft, if you remember, went down and hooked to 2 sun gears down below. Well, we happen to have another housing right here that has teeth. It's called the C1 clutch housing, and it hooks to that shaft, which means if this housing right here turns at all, those two sun gears turn because it's connected directly to it. There's another housing with splines. These set of splines right here are connected to the planet carrier and the ring gear for the P2 and the P3 gear set. And there's another clutch pack right here, clutch pack housing for a C2 clutch that connects to that. So what I'm trying to show you, remember, is a planetary gear set has to get power to flow through it. We have to stop something from rotating, and we also have to force something else to rotate out of those three pieces. So we have a way to touch every sun gear and every planet carrier with all of these pieces. So let me put this together all the way now. Okay. Now, we have on the input side of all of these planetary gear sets, we can connect engine power to the C1 clutch housing, the C2 clutch housing, or this rotating clutch housing that had that sun gear to it. So these three pieces are going to individually or together be connected to the engine somehow. And I'll show you how that happens here in a minute. These ring gears right here are going to be held and stopped from rotating by the clutch packs that connect to them. So in this transmission, we actually have 5 clutch packs. And let me show you one clutch pack right here. This is called the C1 clutch pack. And it's connected right to the input shaft that hooks to the engine. The C1 clutch pack, like every clutch pack, consists of metal plates connected to fiber plates. And as you guys have disassembled or will disassemble your transmission, you've come across all 5 clutch pack sets. I've already showed you the C1 clutch on the input housing. Here's the C2 clutch, or on the input shaft. Here's the C2 clutch inside of this rotating clutch housing. So the C1 and the C2 are inside of that big housing that we just brought over. And those hook to the engine. And then here's the C3 clutch pack. And notice it's alternating steel, fiber, and well, I'll describe how these work here in just a minute. So that's the C3 clutch, here's the C4 clutch, and here's the C5 clutch in very back of the transmission. Okay, so these 3 clutches right here, the C3, the C4, and the C5, they have teeth in them that spline to the case of the transmission. So did you see all those slots in the transmission inside the housing? So these steel plates fit down inside the housing. They will never rotate. They're locked in place with these notches. And then the fiber plates right here, push this out of the way. Here's a C3 clutch plate, clutch fiber plate. Here's where the C3 clutch connects right here to the P1 gear set. So if I just pull those 3 pieces off, notice that the fiber plate splines right to that P3 gear set. So, or I'm sorry, the P1 gear set with the C3 clutch. So this can spin like crazy if it wants, but when we want to stop that ring gear from rotating, All we have to do is somehow act like a disc brake. And so think of this as being a disc brake with multiple rotors. So here's a rotor, here's a rotor, here's a rotor. We've got all these discs. So we'll have a steel plate, a disc, a steel plate, another disc, another steel plate. And we'll just keep stacking and stacking and stacking. The steel plates will never turn because they're hooked to the case. The fiber plates turn because they're hooked to the ring gear. So anytime we want to stop that ring gear, all we got to do is squish these together. Does that make sense?
So the transmission case itself is what's stopping that ring gear?
Yes. Yes. The case itself, through these steel plates, cannot rotate. And so if we can squish all these steel plates together, because they can move up and down this way, then it stops all these fiber plates from rotating, which holds this ring gear from spinning. So what I'm telling you is anytime, let's go back to anytime the C3 clutch is applied, it's going to stop this ring gear from rotating. So now look at your little clutch application chart here. Note, anytime the C3 clutch is applied, it's going to stop the P1 ring gear from rotating. And what gears is it applied in?
Reverse, third, and fifth.
Reverse, third, and fifth. You see that? It's kind of a light green color right here on these charts. So in reverse, we've got the C5 clutch applied and the C3 clutch applied. In third, we've got the C3 and the C1. In fifth, we've got the C3 and the C2. So in certain gears, we're going to stop the C3 clutch from rotating. Now, the same thing is true for the C4 clutch, the next clutch that's down in the transmission. Except the C4 clutch, instead of stopping the upper ring gear, it stops this center ring gear. And the C5 clutch stops the bottom ring gear from rotating. So out of these 5 clutches, these 3 act like brakes. These are going to stop the ring gears of the Planetary gear sets. Does that make sense? These 2, the C1 clutch and the C2 clutch that are in that housing that rotates with the engine when the torque converter transfers power, they are the ones that are going to connect 2 pieces of the Planetary gear set and rotate them. And it just happens to be that they're all sun gears that they rotate. So we've got this bottom sun gear that hooks to the housing that has power transferred directly from the engine without any clutches. So that's a sun gear that's going to rotate. We've got the C2 clutch that splines clear down to the sun gear it's the planet carrier, not the sun gear. Planet carrier for the second Planetary gear set. And then we've got the C1 clutch that splines to both sun gears at the bottom. Now I told you, if you can understand what I'm about to show you here next, the same thing applies to any automatic transmission with Planetary gear sets. The only difference is whether we're taking a Ford or a Chrysler or a GM, a Toyota, it does not matter. I've had them all apart, or versions of different models apart in my classes over the years. They all have these. It's just that where they're located in the transmission might be different. Their size might be different. Which parts are held versus which parts are rotated might be different. But so what? It's all about whether we stop or rotate a piece of that Planetary gear set to get our different gears. Whether it's a 2-speed or a 10-speed automatic, it's still the same principle. Yeah?
How many gears theoretically then could they get out of that one?
Well, usable gear is only 6.
Usable gears are only 6?
Yeah.
Okay.
But a lot more gears, it's just that they would be gear ratios that are unusable. They'd be way too overdrive or way too underdrive.
It wouldn't do anything on the game.
Yeah, they're ridiculous numbers.
So in order for the 8-speed and the 9-speeds that they're coming up with, they have to keep adding usable.
They either add another gear set or they do a tricky combination
to get
thing
it
that
to-
we'll come to later in the class. There's one called a Simpson gear set. There's one called a Peltier gear set. But they're still planetary gear sets. They just connect different pieces together.
It's all about disconnecting.
It is.
That's how they're doing it.
So let's think about all of the parts that you've taken out of this transmission so far. Everything you've taken out of the guts of this transmission is related to clutches. And those clutches, the job of those clutches is either to hold or to turn pieces of a planetary gear set. So I don't care how many clutch packs you have or where they're located, that's their job. So remember I told you inside a transmission I like to think of there being three main groups of parts. This is the mechanical group right here. These are the gears. This is like your manual transmission. But then we've got all the clutch packs that do the holding or the turning of all of those pieces. And then, and we'll come to this later in the week, we've got the hydraulic and electrical portions of the transmission to talk about also, because the valve body is what controls when these clutch packs are applied or released. So we've got the gears, we've got the clutches that apply and release them. The hydraulics do the applying or the releasing of these clutches. The electronics are now controlled by a computer that decides when do you apply and release these clutches. And that's it. That is it. So I don't care if this thing has 367 pieces. Every one of those is totally dedicated to holding or turning one of these planetary gear set pieces and the timing of when it's done and how it feels when it actually shifts. Do you want the shift to bang every time, or do you want a nice smooth upshift? And it turns out it's variable depending on throttle angle and vehicle speed, and so there's a lot of input.
Tow haul mode, it actually changes.
Tow haul
how hard
mode, it changes when and how hard it shifts. Sometimes it even keeps you out of an upper gear depending on which transmission it is. But all of those pieces that seem so overwhelming to me as a young technician looking at another auto trans guy, they were just clutches. And then with the clutches, we've got pistons. These are pistons. You guys have pulled out the C3 and the C4 clutch piston. These pistons are the ones that come in hydraulically and push on these clutch packs to apply them or to release them. And so we'll explore the hydraulics. So we've got a clutch piston for the C3 and the C4. The C5 clutch piston is a little bit bigger and it's spring loaded right over there. The C1 and the C2 clutch pistons are inside of that rotating clutch housing. And so we'll explore those. But let's take a look at what I want you to do today with your planetary gear sets. I'm going to take you through all 6 forward gears and reverse and show you that it's actually pretty easy to do all of this. So looking at the clutch application chart on the back of your 3-ring binder or up on the screen, let's take a look at, let's see, I'm sorry, I got to get the input shaft hooked up here. So here's our input shaft from the engine. It's got the C1 clutch on it. The C1 clutch is not applied, but I can slip this down in. Okay, so our input shaft right here connects to the C1 clutch housing, but notice I can hold the C1 clutch housing from rotating and still turn the input shaft. That's because this C1 clutch is not applied. So that's the equivalent of neutral and park. We don't have any power flow through the transmission. Yeah.
You did say that the Allison goes into neutral every time before it shifts. Is that the same with the other transmissions?
No. No. It depends on the transmission.
We'll get there.
it's very few of them that actually do that. It's called a clutch-to-clutch shift. The others are called synchronous shifts, and they use other pieces called roller clutches and sprags and ratchets. When we do the 6T70, the front-wheel drive transaxle, it doesn't go to neutral in between shifts. It actually completes the next shift, just one right after another, without going to neutral in between.
Is that a 6-speed?
But they're not as heavy duty because all those one-way devices also break under heavy load. And this is a real man's heavy duty, the sound of strength transmission. So they take out all the potentially weak pieces. Okay, so look at first gear. First gear. What clutches do we have to have applied for first gear?
C5 and the C1.
Does everybody see we've got to have the C5 clutch applied and the C1 clutch? So the C1 clutch is right here. The C5 clutch is this bottom one. And so here's our output shaft, here's our input shaft. So all I'm going to do with my hand, I'm going to pretend I'm the C5 clutch. All I'm going to do is come in and stop that ring gear from rotating. And then I'm going to turn the C1 clutch housing, which is the equivalent of this clutch being turned and connected to the engine. And it tells us our gear ratio in first gear is 3.10, so 310 to 1. So I should have to turn this input shaft 3 times, a little more than 3 times, to get one full turn of the output shaft. This rotating clutch housing has to rotate with it. It's splined with it. So these two have to turn together. So here we go.
So you're holding the fifth one steady and rotating.
And turning these two. Yeah. So there's one. It's hard to do with greasy fingers. 2.
So really, that's why first gear on like really old trucks.
3
so
and a
low,
tenth.
It doesn't need it.
So 3.1 turns of the input shaft gave us 1 turn of the output shaft. All I did was held the C5 clutch, which is the P3 ring gear, from rotating. All right, now how do we shift to second gear?
You just hold the C or the C4.
We keep the C1 clutch on. If you notice over there, it says to main pressure, we've got the C1 clutch. But now notice that to solenoid B, we have the C4 clutch. Well, here's C5 right here. Here's C4, here's C3, C2, C1. So we just did C5 for first gear. To go to second gear, we just keep turning the same 2 up here, but now we just move up one set of ring gears. And to go between here and here, we have to go to neutral first, because we actually have to totally release C5 before we apply C4, which gives us no power flow through the transmission, which is that timing issue that we talked about. So now, second gear is 1.8 turns of the input to 1 turn of the output. So here we go. Here's our output sticker. So here's 1 complete turn of the input and 0.8 of a turn, and we get second gear, 1.8 to 1. Right? How do we shift to third?
C3 and C1.
C3 clutch. So here's C5, C4. Now we let go of C4 and we apply C3, and we still turn the C1 clutch. But now we've got a gear ratio of 1.4 to 1. So I'm going to hold the C4, I'm going to turn the C1 and the rotating clutch housing together. Notice the output shaft spins much faster. And now there's 1.4 to 1 turns. Let's go from fourth gear to fifth gear. What's fifth gear ratio? No, I'm sorry. We went from third. Let's go to fourth gear. Fourth gear ratio is 1 to 1. So now we've got to have the C1 and the C2 clutch on. So now, here's the C1 right here, here's the C2 right here. Notice we're not holding anything. That's because we're in direct drive. Remember I told you in direct drive we don't hold anything. We pick any 2 pieces and turn them together. So quite simply, I grab these 2 pieces and I get 1 turn in equals 1 turn out.
Wait a second, could you do that with any other 2 pieces, or does it have to be?
Could be these 2. It could be these 2. Any of those 3 will give you a 1-to-1. It's just in this transmission, those are the 2 easiest ones. Right now, let's go to 5th gear.
C3 and C2.
We have to go back and apply the C3 clutch, but now and hold it from rotating, but now we're going to turn the C2 clutch housing rather than the C1. Now this is overdrive of 0.7 turns of the input to 1 turn of the output. So I'm going to hold the C3, turn the C2 and the rotating clutch housing. It's a lot harder to turn. Notice the output shaft is turning much faster.
It's harder to turn though?
It's harder to turn because you're in overdrive, yeah.
Then how does that make better fuel economy? If it's harder to turn.
It only does it on nice flat roads, and you've got an engine with a lot of torque. So that's a 0.7 to 1 overdrive in 5th gear. Now, beginning in 2006 model year, and by the way, these are the guts out of a 5-speed, but let's do 6th gear anyway. How do we get 6th gear on a 2006 and above?
C4 and C2?
C4, which is this one, instead of the C3 in 5th. So we're going to keep turning the C2, but now we're going to hold the C4. So now we'll get a 0.6 to 1 overdrive ratio. Notice it's turning much faster. There's our 0.6 to 1 gear ratio. All right, the only gear left that we haven't done is reverse. So how do we get reverse?
C5 and C3?
C5 and C3. So I'm going to hold C5 and hold C3. And then I'm going to turn the rotating clutch housing that's directly connected to the engine. So we're not using C1 or C2 at all. But notice now, let's see, we've got a 4.49 to 1 gear ratio. Notice now it's turning backwards, and
Wow.
it takes 4.5 turns. So reverse is quite a reverse to get us back to 1 full turn. So now just a couple of things to get finished up with this Planetary gear set demo. I want all of you to be able to do that same thing that I just did. First, put all of these pieces together, just like I put them together. Feel free to come up and look at this, how it's assembled. But then I want you to have me come around and verify that you know how each gear is obtained. But let's talk troubleshooting here for a minute. What if the C1 clutch never worked? What if it didn't work?
First or fourth would be in trouble.
Everything that it's used in on that chart, every gear it's used in would not work. Does that make sense?
It's a really diagnostic. If you know it's spinning, you can figure out what's wrong.
Yeah. Would reverse work?
Yeah.
It would, because C1 is not used in reverse. Only C5 and C3.
Wait a second. If first through fourth don't work, the customer's not going to come in and go, well, I can get it up to 5th by starting, or would it just jump to 5th below?
They would complain that the vehicle won't move.
Okay. So if you had the C2 clutch pack go bad though, they would say it won't go into 4th. It would
Exactly.
lock out.
So if C2 were bad, we'd have 1st, 2nd, and 3rd, but not 4th, 5th, or 6th. But notice reverse would still work, because C3 and C5 are used for reverse. But now let's talk about C3, and this is a common failure on a lot of transmissions, not particularly the Allison, but what if the C3 clutch failed? What gears would not work? Reverse, 3rd, and 5th. So if anyone says my reverse doesn't work, you want to also go drive it and see, does 3rd also not work? Because that is a diagnostic, it's the same clutch that's required for both of them, and you want to have an idea of what's wrong with the transmission before you take it apart. Yeah.
The transmission we're taking apart next week is the one out of like a Traverse, right?
Mm-hmm.
There was a TSB where the customer would complain of no reverse, and so it would lock it out of those gears, and that's why, because the clutch pack, that wave plate.
It was a
has failed.
common clutch pack to something else. All right, let's look at C4. If C4 didn't work, we would not have second or sixth. And then the big one, C5, if C5 didn't work, would the vehicle move at all? Forward or reverse?
No.
No way. So if the vehicle doesn't move at all, C5 is probably not working for whatever reason. However, you cannot assume that it's inside the transmission. It could be an electrical problem, it could be hydraulic, it could be mechanical. But you know that something related to the C5 is the only thing that can prevent you from reverse and first, assuming that hydraulic pressures are still okay, and so on. So, one more time, Planetary gear sets. I don't care who makes the transmission, they all have Planetary gear sets. All of them have parts that are held and turned to get different gear ratios. All of those pieces all over your benches are either the Planetary gear sets, the clutches that hold them or turn them, or the hydraulics and the electronics that control whether or not they're held or turned. And that's it. So that should help simplify in your mind all of those pieces. And of course, putting it back together will help seeing those pieces and doing another transmission. When we take apart that 6T70 next week, you're going to see 3 more Planetary gear sets, but they're going to be these little baby ones. But you'll recognize same things: Planetary gear sets, clutches, hydraulics, electronics, and that's it. So that's why I say if you can understand this transmission, which is the easiest one to learn on, the rest of them come much more easily. All right, let's get to work.
John?